Recording in progress.
Right, welcome and thank you so much for coming through. My name is Xolani. Most people call me Mr. X, and welcome to my mathematics free class for 2024. And we're starting the year on the right path as we are joining this particular free lesson. I am going to be dealing with a grade 12 topic in mathematics series. That's the topic I'm going to be dealing with. It's a partner to a topic known as sequences, as you can see right here on the poster. So welcome and thank you so much for attending this particular lesson. Okay, so here's what I do particularly. I am an educator. I am also a tutor, and I deal also with online classes, as you can see right now. So whenever I do my lessons, all my lessons are 2 hours long, just like what this one will be. And as of last year, the lessons were 2 hours long, costing 100 rands for a 2-hour lesson. But this year I have slashed the prices, believe it or not. I've broken down the record and I'm saying, why should we have it for 100 rands for a single session? Let's have it for 50 rand for a single session. But here's the catch. Each student must attend 2 lessons at a time. In other words, you won't attend just 1, but 2. So that means you pay 100 rands for 2 lessons, 100 rands for 4 hours instead of 2 hours as of last year. All right, so it's going to be an exciting time. I will be starting this big lessons on the week of the 26th of February. So what happens is that every single week we'll do a lesson on maths and do a lesson on physical sciences. So every single week we'll do 1 lesson maths, 2 hours, 1 lesson physical science. The other week could do the same, 1 lesson maths, 1 lesson physical science. And if you've done 2 lessons, that means you pay 100 rands. And then in a typical month, there is about 4 weeks. So that means if you want to do 1 subject, you just simple have to pay 200 rands for the whole month. That is 8 hours for 200 rand. That's like so cheap. And then if you want to do both subjects, both maths and physical sciences, that'll get you to 400. So I will be starting the bookings sometime next week so that I know who's coming and I prepare for them from that particular perspective. But otherwise, we're going to have a great time as we start to learn. Now, during the course of the lesson, I want you to be able to ask me as many questions as possible, but allow me to just lay down the background for what we're going to do. If you do not understand something, you can always send a message on the chat, or you can always lift up your hand. And I want you to understand also as well that during my particular lessons, as I do them, even this example of today and the ones that I'm going to do starting from the week of the 26th of Feb, every single lesson has got a PowerPoint. It has got diagrams, it has got questions, things that help you to understand. And when I teach, I come from a level of small where I deal with the abstract that looks complicated, and I bring you to something that you, at the end of the day, will understand with all exam tips and resources and so forth and so on. All right, I'll talk more about this even in our groups. For now, let's get ready. I'm going to deactivate my video because now we're doing serious things. Get your books ready. Calculators ready, everything ready, and we are doing the topic series right there. Write it down, and we are doing the topic series right there. Okay, I'm ready. Here we go. Now, when we speak about a series in maths, we are saying to ourselves, if you have a sequency, let's say you've got a sequency, and in your sequency, you've got, in this case, term number 1, and you've got term number 2 and term number 3. T1, T2, and T3. That denotes a sequency. Then the sum, when you add the terms of a sequency, we call that a series. So the addition of the terms of a sequency is series. So T1 plus T2 plus T3, we are speaking the language of series from there on. So I want you to understand that there is a sequency, T1, T2, T3. The addition of the terms of a sequency in mathematics is known as a series. I did put a definition here where I said a series is formed by adding the terms of a sequency. Therefore, the sum of any terms in a sequency is called a series. All right, perfect. Here we go on that one. Here's an example. The sequence is 3, 6, 9, 12, 15, and 18, just a basic sequence. And if you go back to the topic sequences, you will remember that this is an example of an arithmetic sequence. I'll talk about it as going along. So the sequence is what you see there. When you talk about a series is when you're adding the terms. That's 3 plus 6 plus 9 plus all the way up to 18. Though this particular sequence continues plus 18 plus, so goes the story. And here's another example here. Look at this interesting one. I've got 5, I've got 2, I've got -1, I've got -4. The terms of a sequence. And so when you deal with this one here and you are adding and it becomes a series, we're saying 5 plus 2 plus -1. That's one of the terms there, plus -4. And look at what it becomes. 5 plus 2 minus 1 minus 4. Let me just give an idea so that people can understand what I'm talking about. Notice that the plus and the minus will give you a -1, and the plus and the minus also will give you a negative. So you're adding 5 and 2 and -1 and -4. And in mathematics, again, this is called basically a series. All right, let's go to more stuff that we need to know. Now, when you are adding the terms of a series, we say in maths, you are summing the sum of the terms of a series. And so in maths, we say you are SN, is SN, the symbol SN is the one used to denote the sum of the first n terms of a particular series. So SN, where n is the number of terms that you're adding. Look at this example that I have. So if you're given the following sequence, and it's 1, 4, 7, 10, and 13 for that one, then if you are going to deal with the sum of one terms, S1. Now, if I look at what S1 is, it means I am summing the first term, or I am summing one term. And in this case, note that the S1 sum of one term is actually the first term. I want to say this again. This is very important, especially when we start doing the complicated questions. The sum of one term, you're adding one term, and the first term that you have there is just 1. So the sum of one term is actually the first term, T1. So S1, sum of one term. And I think if I say S2, it means sum of two terms. There you are. So it's S2, which is 1 plus 4, which is equal to 5. Sum of the first two terms. S3, I add the first 3 terms. S4, I add the first 4 terms. So goes the story over and over again. So basically what you're simply saying is that S anything, Sn, means the sum up to n terms. Sn, S2, sum of 2 terms. S3, sum of 3 terms. S5, sum of up to 5 terms. So the general idea or the general thing to note as we start with the basics, and I want you to understand when I teach, I don't assume anything. I teach from basics. Therefore, when you're dealing with a sum of up to n terms, you're adding from term number 1 up to term number n. So if it's sum of 4 terms from term number 1 up to term number 4, sum of 5 terms from term number 1 all the way up to term number 5. All right, perfect. Let's go to the most exciting one. Now, just like in maths, we have an arithmetic sequence. We also in mathematics have an arithmetic series. Now, it means that if I'm dealing with an arithmetic series, my concern is about adding the terms of an arithmetic sequence. Listen to my English here. The arithmetic series, you are adding the terms of an arithmetic sequence. So an arithmetic sequence series is the sum of an arithmetic sequence. So I need to have an arithmetic sequence, add the terms of the arithmetic sequence, I end up with an arithmetic series. And how do we do this? How do we calculate the sum of an arithmetic series. Now, let me give context. It's very important to understand that, let's say, for an example, you've got a certain series. Let's say it's 2, and then here it's 5, then here it's 8, then here it's 11. And somebody says, please find sum of 4 terms. That should be relatively easy. 2 plus 5 plus 8, and then plus 11. That's fine. But let's say this particular sequence continues, and somebody says, please find sum of 100 terms. Now, that's going to be quite tedious when you think about it. When somebody says, please find the sum of up to 100 terms. So it's going to take you a while to end up getting the 100 terms on the sequence so that you can add them, and it gives you a series. So then how do we solve that problem? The problem of trying to find the sum of 100 terms and not having to go through the process of finding each single term. And so how do we do that? We do that using formulas. That's why my statement says the formulas for calculating the sum of a finite arithmetic series are given below. Here's the first formula. This will be part of your formula sheet. You will find it there. And it says sum of up to n terms is equal to n over 2, and then square bracket 2a plus n minus 1, all this multiplied by d. This is a formula for calculating the sum of the terms of an arithmetic series. Let's talk about what each letter stands for. N stands for the number of terms in the series. Are you summing up to 10 terms? Are you summing up to 50 terms? So N is the number of terms that you are summing in that particular series. There's another letter, Sn. The symbol Sn is the sum of n terms of the series. So say, for example, you're summing up to 7 terms. So the n would be your number of terms that you're summing. S7, you're summing up to 7 terms. All right. There's more letters. I want us to know them so that when we're using the formula, we understand where we're coming from. D is an arithmetic series, so there is a common difference. So D is the common difference. Now, if I was to jog your mind back to the topic sequences, you should be able to remember that if you have a certain sequence and it's arithmetic in nature, your particular D is always the term in front, 5 in this case, minus the term before, 3. I can go further and confirm it. The term in front, 8, minus the term before, 5, 3. And so again, I can confirm it. Term in front minus the term before. This is known as the common difference. All arithmetic series have a common difference, and when you're summing up, D is your common difference. And then also, a letter that's quite important is the letter A. The letter A stands for the first term of that particular series. In the example that I've just been giving, 2, 5, 8, and 11, your A, your T1 would be the value 2. So that's very important to remember. So this is the formula that we can use. So we'll use this in many different circumstances. And I want you to understand that the questions come in different forms. Sometimes they can ask you to calculate N, the number of terms that you are summing. Sometimes they ask you to calculate A, the first term, or D, or even the sum of N terms. Interestingly, your syllabus requires you to know how to actually come up with this formula. For today's lesson, I will not teach you this, though I will teach it on my other lessons as we go through the entire year. There is another formula, though, that we use to calculate the sum of n terms of an arithmetic series. This one says Sn is equal to n over 2a plus L. This particular formula is used under exceptional circumstances. What do I mean by that? For you to use this formula, you need to have your n, which is still the number of terms in the series. You need to have your Sn, which is what you're trying to sum up. You need to have your first term. But look at the last most important thing, the letter L. The letter L stands for the last term of the sequencing. So the letter L stands for the last term. So in this formula, and please do not forget this, circumstantially, we're going to use it in a situation where we know the last term of that particular series. If we don't, we can always go back to the first one that I told you about. Either of them are applicable. All right. Having said that, I want to do a couple of questions that will help us to understand how to use this particular formula. All right. I've got a couple of practice examples here that I'm going to do with you. Get your calculator ready and let's begin. So you can write practice examples on arithmetic series. All right, I think people have written this. Let's begin. I'll start with question number 1, do a couple of things, and some I'll allow you guys to do as well. So let's start with question number 1. Find the sum of each of the following arithmetic series. Find the sum of each of the following arithmetic series. So I've got 5, I've got 8, I've got 11. It goes further on, and it says up to 20 terms. So let me start with A. All right, so 1A, let me notice the following. My first term is 5. That's T1, first term is 5. Then I notice that I can get D, my common difference, the guy in front minus the guy before, and I think I get 3. I can confirm it. The guy in front minus the guy before, so that's 3. Then I'm summing up to 20 terms. So the number of terms that I'm summing in this question is 20. So I'm looking for S20. So I'm writing my information. I'm looking for S20. Notice that I don't know the last term. So I can't use the formula that I said you can use when you got the last term. I go to the one like this. Sn, excuse my writing, is n over 2. Get your calculators out. N minus 1 multiplied by D. What am I looking for? Sum of up to 20 terms. So I'm adding first term, second term, third term, fourth term, fifth term, sixth term, up to 20 terms. The number of terms I'm adding, N is 20. First term, what am I? I am 5. N, the number of terms, minus 1. Common difference is 3. I need your help. Please type your answer so that we can all get all involved. So that's my first one right there. Sum of up to 20 terms of this particular series. Okay, guys, let's go with the answers. I'm confirming 670. Thank you so much. Much appreciated. So the first one is 670. Let me do B quickly. Then you can write what you need to write. Remember, this will be posted on our YouTube, so you can always go back and follow through as much as you can. Thank you. I appreciate the way you're participating. Let's keep working. Look at the next one. -14, -9, -4, plus. I'm summing up to 100 terms. First term, I see you are -14. Interestingly, when you look at this, this is as good as saying -14 plus -9 plus -4. That's what it is, exactly that. So your first term being your -14, your second term being your -9, and your third term in this case being your -4. And so because it's an arithmetic series, we may need to find our D, and our D is always the guy in front. Who are we? -9, -14, -9, -14. That means at the end of the day, my D is equal to 5. You can confirm that even from this one, where you say -4, -9, it also gives you a +5. So I found my A, I found my D. How many terms am I summing? 100 terms. N is equal to 100. I'm looking for the sum of up to 100 terms. I do not know it. So eventually, at the end of the day, I think I'm going to ensure, let me just put this through. I think I'm going to use my formula, the one that I've already posted here. So I'm just going to substitute the numbers here. Let me use a different color pen. Here we go. So S100, get your calculators ready. N over 2, 100 over 2. 2A, that's 2 times -14, plus N minus 1. That means I'm dealing with 100 minus 1. All this multiplied by D, which is 5. There you are. I would need an answer for that one there. I think some of you guys are already doing this. Right, 23,350. Thank you. 23,350. Perfect. I'm ready for my next one. That's just one A and B. Something quite simple. We're looking for the sum of 20 terms, the sum of 100 terms. Write this down. I'm going to take this out in about 10 seconds or so. I'm ready for 2A, and 2A looks a bit more interesting. I'm going to do 2A, then I'm going to allow you guys to do 3A and B. So I'm going to do the whole of 2. Then you guys are going to do the whole of 3. I will time you. Then we revise and keep going on and on like that. I'm about to take this out. There we go. Gone, 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 going. You can always take screenshots of this any particular time. So we're good to go. I love your participation right there. Somebody's getting a different answer. I think you can always go back and try and re-add. The answer is 23,350. Gone, gone, going. Perfect. The next question. 2A. It says, how many terms are in this series? How many terms are in the series? And I've got the -3, I've got the 1, I've got the 5, and it looks like we have a last term, the last term being 313. Now listen to how I teach this. Listen to my question, and I want you to answer it on the chat here. If I say it to you, the 6th girl is the last girl in the queue. How many girls are in the queue? Let me say that again. The 6th girl is the last girl in the queue. How many girls are in that queue? Think about it, Chuck Norris. Don't be too quick. Ibambe lapho boy. Ngithi mina, the 6th girl is the last girl in the queue. How many girls are in that queue? Also, let me see the answer. But 6. 6. I see 7. The 6, someone says 5. Yes. As you can. All right, so let's think about it. The 6th girl is the last girl in the queue. How many girls are in that particular queue? Right, I played with your mind right there. The answer is 6 girls. Okay, look at this, fam. I want to teach you this. Girl 1, girl 2, girl 3, girl 4, girl 5, girl 6. So girl 6 is the last girl in the queue. So here's what I want to teach you in maths. Here's what I want to teach you. The position of the last term in a sequence or series will give you the number of terms in that sequence or series. I will repeat it. The position of the last term gives the number of terms in the sequence or in the series. Write it down. I'm saying it again. Write it as I say it. The position, now so, the position of the last term, the position of the last term gives the number of terms in the series or sequencing. The position of the last term gives the number of terms in the series or the sequence. Let's do some math. Here we go. 2a. How many terms are in the series? So we go back to the statement that I said you must write. Apparently, from what I just wrote, it means the position of the value 313, which is the last term in this series, will give us how many terms they are. And so because it's an arithmetic position, I go back when I did the topic, arithmetic sequences. Tn is A plus n minus 1d. Like I said to you in the beginning, this topic is a partner to the topic sequences. You start by doing sequences, then you do series. So Tn is actually the value, the last value in this case, 313, A being my first term, plus n, which in this formula is the position of that value. Then d, if you think about it, you can always say 5 minus 1, it gives you 4. Or you can always say 1 minus 3, it still gives you 4. So I have my d as 4 right there. So I need you to get this right. If you were to deal with the topic sequences, this is what you would actually do. You need to notice two very important words. This is a value. Its position is position 1. The value, -3. The position, position 1. 5, the value. Its position, position 3. 313, the value. If I find the position of 313, I find the number of terms in the series. Why? I say the statement, the position of the last term in the series gives the number of terms in that particular series. So in this case, I do math. 4 times positive n, that's plus 4n. Then here, 4 times -1, -4, 313. I'm good to go. -3, -4. That gives me -7. We're doing it old school, step by step. 313. I take -7 to the other side. I get 320. 4n. I'm looking for the value of n. At the end of the day, n is equal to, in this case, 80. In other words, the value is 313, but its position is 80. So T80 is 313. What's the question? How many terms are in the series? Therefore, because it's the last value, then its position will determine the number of terms in there. So that means, therefore, the number of terms is equal to 80 from there on. So this is what you get there. The number of terms is 80 right there. Somebody says, is it possible to use the second formula? Yes, when you're doing B, the sum. Here on 2A, we're not looking for the sum of the series. We're looking for the number of terms in that particular series. So n is 80. That's number 2A. Please don't confuse sum of and position, right? So here we're looking for how many terms are actually here. The next question says, what is the sum of that particular series, which is what I'm going to deal with. So we're now dealing with the sum of 80 terms for the next question. Let me just do it on the side here. Now, luckily for us, we have a last term. We do have a last term. And so because we've got a last term, we can actually find or use the formula Sn is equal to n over 2. Then here A plus L, because we do have a last term. So n, 80 terms, I'm summing them over 2. A, that's -3. L is 313, 313. Eventually, you're going to get this as your final answer. You tell me what the final answer is when you add them all together on that one. Somebody says 12,400. I believe that, 12,400. So we've used the second formula, but I also want you to know that even if you use the first formula, you still get the same answer. Regardless of whether you used first or second, you will still get the same answer. All right, now that we're all here and maybe we understand all of this, I want to give you 3A and 3B, and I'm giving you about 3 minutes to actually do both questions. I'm going to mute myself while I read some of your questions as you go on along. 3A and 3B, 3 minutes. Your time starts now. All right, we should be done now. Let's do this together as a team. Again, we've got a question that's similar. Says, how many terms are in the series? That's 3A. Last term being 32. Now, we need to confirm a couple of things. Is this an arithmetic? Yes, definitely, because we are doing arithmetic, not yet geometric. We're coming to it soon enough. How many terms are in this particular series? Okay, let's do it together and see if we can win on this one. Okay, so Tn is A plus N minus 1 multiplied by D. And we're saying the last term is my 32. My first term is actually a half. Then N, the position I do not know. And if you think about it, I can find my D. How did I do that? I could say 2 minus a half right there, which at the end of the day, you get the value 3 over 2. If you wanted, you could have said 3.5 minus 2. You still get 3 over 2. Then the rest is algebra, maths. The brackets should open. 3 over 2 times that, that's 3 over 2n, minus, in this case, 3 over 2. So now you've got a half minus the like terms here, a half minus 3 over 2 right there. And I think you get the number, which is -1 plus 3 over 2n. So you've got a half right there minus 3 over 2. Now, guys, I want you guys to be very clear on the algebra because it's important to actually get the algebra right. Otherwise, if you mess up, you won't get the right answer. Still got my 32 here. Still got my 32 right there. It's like 33. When I take the -1 to the other side, 3 over 2n. Then eventually, You got 33 divided by 3 over 2 so that you can get the n. So the number of terms that are available is 22. So when you write it down in math, we say T22 is equal to the value 32. But again, according to our statement, because it's the last value, then the position of the last term gives the number of terms in that particular sequence. So we've got 22 terms, therefore 22 terms. And let me just run to B quickly. I think I have a feeling you got this. I have a feeling, Inyana, that you might have got this right there. And so the next one then says, what is the sum? Just like what we did for 2B. Okay, I can use either formula, but hey, in maths, time is my worst enemy. I'll use the second formula, n over 2a, which is a half. You guys give me the answer, plus the last term, 32. What is the sum of 22 terms right there? Somebody says 760. Can we confirm that, family? Yes, we can. All right, perfect. These are just your simple examples on E arithmetic series. I've got more. The next page has got even crazier ones. I'm going to do a couple of them, and then I'll run to do E geometric series. All right, let's go further on that. Gone. Going, gone. Okay, I think you guys got it. I'm very proud of you. You did very well. So if you didn't and you have a question, please always be ready to ask me. I'm gone. There we are. Let's try the next one. There's a next slide here, which is quite interesting. Number 4 says to us here, how many terms of the arithmetic sequence 3, 11, and 19 will add up to 1,580? Okay, that's interesting. How many terms of this particular sequence will add up to 1580? So here's the point. I'm looking to find out how many terms when I add them will eventually get me 1,580. Is it 10 terms? Is it 100 terms? How many terms do I need to add so that the sum of those terms amounts to 1580? Somebody has a hand. I want to unmute. Go ahead. I am all ears.
So for the previous question, 3B, can you please check the answer again, because I'm getting a fraction and you guys said the answer is 760. I don't know if I'm the only one.
Okay, so you want us to check if that's a different one altogether? All right, so this question here, right?
Yes,
that's 22 over 2, a half plus 32. Guys, please do confirm. Is it 760 or what? Please give me the answer so that I know. I remember I'm depending on you, right? Somebody says I'm getting 357.5. Okay, somebody had said 760 and others had agreed on it. Someone says 715 over 2, which is still the same as 357.5. So let's go with that one there. Okay, so then it means that whoever typed that one took me for a ride. So it's actually 715. Thank you for giving that out to us over 2. You could leave it as a fraction or you could leave it as that decimal. Thank you for that one. Let me quickly go to my next one. Thank you so much. Appreciate on that one. I'm ready there. So guys, let's make sure that we pull through on that and see how far. Number 4, I'm ready. How many terms of the arithmetic sequence 3, 11, 19 will add up to 1580? And so I was giving the idea behind this question to say, is it 10 terms? Is it 15 terms? How many terms add up to 1580? So let me write my information here. Let me write my piece of information. So how many terms add up to? Let me write my information. Let me see what I have. So I think I've got my first term. I'm doing number 4. My first term, let me write it on the side here. So my first term is actually 3. And then I think I can get my D. Nicely put, my D should be 8y, 11 minus 3y. Next term, 19 minus 11. So my D should be 8. And then the sum of those terms is 1,580. And then also as well, I do not know what the number of terms is. So here's my situation. I know that the terms will add up to 1580, but I don't know how many of them will add up to 1580. Let me run to my formula. Let me run to my formula, put my stuff in there. Let's do some algebra, some mathematics. Here we go. Here we go. Sum of terms is 1580 is equal to n over 2. I don't know how many terms I'm supposed to add so that they can give me this number. The first term being my 3, my n number of terms, very clueless, my d being 8. We do the math. So it's now still n over 2. Let's deal with inside. Here, 2 times 3, I see that I'm going to get a 6 plus, I open the bracket, n, 8n minus 8. Here we go. I've got 1580. See, I'm looking for n over 2, I see you. Then I've got here 8n is positive, 6 minus 8, that's negative 2. Then I've got 1580 as well. Now, the problem is that I have a fraction somewhere, the over 2. Let me try and get rid of the 2. How do we do that in maths? We cross multiply everything by 2. So I'm going to multiply the side by 2. 3160 is equal to n. Then here I still have the bracket 8n minus 2. All right. So far, I think we're okay. You let me know where there's a struggle or anything. I'm just doing algebra, opening brackets, adding numbers, cross multiplying. And then eventually brackets will open again. 8n squared, I see you, minus 2n, then 3160. It looks like it's going to end up as a quadratic equation. Okay, how do I know? Well, I can take this 3160 to the other side, 8n squared minus 2n minus 3160. I'm looking for the number of terms that will add up to 1580. Now, it's possible now that once you've got this, you can use the quadratic formula where your a, coefficient of n squared, is 8. Your b, get your calculators ready, -2. Your c, -3160. And so if we use the quadratic formula, it says n, in this case, minus b minus 2 plus or minus root of b squared minus 2 squared minus 4, right? Minus 4a, the a being 8, the c being -3160. I need your answers there. All of this over 2a. All right, let me get my values of n right there. N is equal to, or n is equal to. Get ready with the quadratic formula. Let me see what people are saying. Right, somebody says n is 20. I hear 20 confirmed. And then there should be another n that should be, I think it should be negative, and it should be a fraction, something like that, right? Somebody says -19,75. All right, yes, I agree with that. So it looks like at the end of the day, fam, the number of terms cannot be equal to a negative number. You can't add up to negative numbers. No. So this one is non-applicable. So it looks like to me, the sum of 20 terms is the one that is able to give me the sum. Okay, if I sum up to 20 terms, I end up with the number 1580. So that's where the answer is. Talk to me if there's an issue or a problem. I actually want to do my next one and quickly run to the geometric sequencing, which was geometric series, which is quite interesting. Right, so that's your answer for number 4. And I just want to give you a pointer. Even number 5, you do the same way, something similar. All right, I'll send this document to the WhatsApp groups that I have so you guys can actually go through some of the stuff that I will not go through in this lesson so that everyone can fully understand. All right, I'm ready for my next one. So n is 20. You must always say non-applicable, or you can say n is not equal to, let's do this if you want, right? But anyway, any of them will be fine. So n can never be a negative number from there on. Right, somebody says, please explain again from the squares. I did not get that say. Okay, so basically what you're doing, this is a quadratic equation. And when solving a quadratic equation, you have options to use the quadratic formula. And so I used it here. And just so that you may know, one of my first lessons when I start the paid lessons, I'll do algebra. And if you didn't know, algebra, for me, if you ask me, and I've experienced in teaching, algebra is the most important topic in maths. Every topic in maths has algebra in it. From Euclidean geometry to trigonometry to analytical geometry to statistics to whatever, every single topic will bow down to algebra. And it's 25 marks in the final examination. They're up for grabs, and I will start off with that one. So I used the quadratic formula. Algebra, like someone said, is the mother, definitely, of mathematics. All right. Having said that, let me quickly take this out. So I used the quadratic formula, going. I want number 7. I want number 7. I want number 7. There's number 7. I'm just going to jump from number 4 all the way to number 7. All right, before I do number 7, I want to just show you something and then work with me from this thinking perspective. All right, arithmetic sequencing. Let's visit it. Tn is equal to A plus n minus 1d. That's the general term of an arithmetic sequencing. That's Tn. All right. And then I want you guys to get this idea. If I'm looking for T4, as an example, T4, it's actually A plus 4 minus 1d. Eventually, T4 is A plus 3d. That's what T4 is, A plus 3d. All right, so T4 is A plus 3d. Let's just try another one. Check this out. Check this out. Somebody says, okay, fine, find T9. Find T9. All right, T9 will be A plus, where there's n, I put 9. 9 minus 1, I get 8 times the d. That becomes 8d. So T4 is actually A plus 3d. T9 is A plus 8d. I can do this with anything. I can do this with anything. I can say T13 eventually is going to be A plus 12d. N minus 1. N minus 1. N minus 1. And so if I say T100, you tell me, type it down for me. T100, T100. What will I say? What will I say? Right? 10, T100. What do I say? A plus 99D. Thank you so much, family members. Really appreciate. So it's 1 less. If it's 9, 8D. If it's 4, 3D. If it's 13, 12D. If it's 100, 99D. So goes the beautiful long story. And now we read our question number 7. All right. Someone says, please repeat. And all, okay, I'll take that. I'll take that. This is what I was saying. I just need you guys to get the idea behind how you play around with this in terms of math. So if you're looking for the 4th term, you go back to the original equation. Your n is 4. It's just 4. Your n is 4. Your n is 4. 4 minus 1, that gives you 3, 3d. So T4A plus 3d. And if you're looking for T9, A plus 8d. So it's always 1 less. Just to help you and ease your mind, 1 less, 1 less, 1 less. So T100 will be A plus 99d. 1 less. I want to go back and read my question. The sum of the first 10 terms of an arithmetic series is 145. I write what I read. The sum of the first 10 terms of an arithmetic series is 145. I write what I read. We continue. And the sum of its 4th term and 9th term is 5 times the 3rd term. All right. Say what you're saying. The sum of its fourth term, I write what I read. I write what I read. What am I reading? The sum of its fourth term, T4, and its ninth term, the sum of the fourth term and the ninth term, what is it? It's 5 times the third term. 5 times T3. Determine, the question says, the first term and the constant difference. Determine the first term and the constant difference. Let's not miss the train here. Okay, stop the bus. Where are we going here? Where are we going? Stop the bus. The bus is saying sum of up to 10 terms. When you add the first 10 terms of a typical arithmetic series, you get 145. Okay, Seutin. I'm saying S10, all right, is equal to N over 2, 10 over 2. Okay, all right. 2A, the first term, I don't know it, plus N, 10 minus 1, multiplied by D, right there. And what is S10? What is S10? S10 is 145. So the first statement, this statement, is actually mathematically written like this. And so I can play around with maths because something is wrong here. I have two unknowns. I don't know A. I don't know D. That's what I'm looking for. First term and the constant difference. 10 over 2, that gives me 5. Let's do some maths. 2A, I see 9D. There we are. So maths is maths. Then I say to myself, okay, can I go for 10A? Yes, I can. Can I go for 45D? Yes, I can. Can I go for 145? Yes, I can. Apparently, I'm still stuck because I got two different things in one equation. My mind is going to the topic simultaneous equation. I've got two unknowns right there. Okay, all right. Can we do something here? 145, 10A, and there 45D. Is it possible to divide everything by 5? Yes, it is. If I divide 145 by 5, I get 29. If I divide this by 5, I get 2A. If I divide this by 5, I get 9D. It's just playing around with math. You can still leave it like this, you'll still get an answer. Basically, that's what you have. So here's my first equation. Taken from the statement, the sum of the first 10 terms is 145. Okay, all right. Let me try my second part. Let me put a boundary here. T4. Last time someone told me in this lesson that T4 is A plus 3D. T4 plus T9, somebody told me that T9 is A plus 8D. All this is equal to 5 times the third term, which is A plus 2D. All right. And we pull through. Okay, so I'm thinking now. So this is A plus A. I see 2A. This is 3D plus 8D. I see 11D right there. This is 5A, open the brackets, and then 2D, that's 10D. Okay, let me do the math. I can take the D's on the other side. D is actually equal to 3A, equation number 2. Okay, say, stop the bus, man. Why is this bus moving so fast? Hi, man. What's happening? 11D minus 10D is D. 5A minus 2A is 3A. So now I've got equation 2 and equation 1. And mathematically, I can say 2 gets into equation 1. We bring it down here. So 29 is equal to 2A plus 9. What is D? D. 2 into 1 is 3A. We do some math. I got 2A. 9 times 3A is 27A. That gives me 29A. Still got the 29 on the side. 29. And I divide A is 1. Determine the first term. A is 1. Can I get my D? Yes, I can. D is 3A, 3 times 1. So D is equal to 3. Using English, we came up with mathematics, and eventually I got to that part. And somebody saying, how did you determine that T4 is A plus 3D? It's what I said before, family members. It's what I said before, where I said A plus N minus 1 multiplied by D. And I said A plus where N, T4, 4 minus 1, that's 3D. Remember, I said it's one less, and all that. Okay, let me go back to the same question. All right, you'll be fine. And I think, listen up, it's our first lesson. You guys are trying to learn what kind of person I am. And I'm also trying to learn what kind of students you are. We'll eventually get to a point where we all gel together and all that. Let me run this through one more time. All right, somebody says, oh, I'm fast. No, you listen slow, Antoine. Guys, just have fun in the lesson and take it up from there. Now, so I'm gonna start. Maybe write this down, then I'll go through this. Got your back, boy. Got your back. All right. Write this down, then I will run through this. All right. I'm ready, fam. I'm ready. I got your back. I'm ready. All right. What we doing here? What we doing? So here's the point for me. Ne? Here's the point. Read the English and translate the English into maths. Read the English and then translate the English into mathematics. The sum of the first 10 terms. All right. So I'm getting that. The sum of the first 10 terms of an arithmetic series is 145. I write what I read, S10. Sum of 10 terms is 145. When I put it across in maths, S10 is 145 is equal to N over 2, 10 over 2, 2A, N minus 1, 10 minus 1 plus D, multiplied by D. And then the rest is mathematics. 10 over 2 is 5, 2A plus 9D. If you look at it, and I trust your brain, I really trust you. If you look at it, you will actually understand it, right? You will get it. Whereby then I said 145 is 10A, I've opened the brackets plus 45D. Then I made my life easier. Say, oh, but I can divide everything by 5. So then 29, 2A, 9D. That's just on the first statement. Then the one that's giving people a run for their money, it says, and the sum of its fourth term and the ninth term is 5 times the third term. It says, so the sum of the fourth term, that's T4, and ninth term, that's T9. When you add the fourth term and the ninth term, it gives you 5 times the third term, 5 times T3. And so at the end of the day, I say, but T4, having learned from the previous thing, T4 is A plus 3D, and T9 is A plus 8D, is 5 times. 5 times, you multiply times, 5 times. Then you multiply, eventually you end up here. And because now D is 3A and you got the first equation, you can just bring it down together and eventually you're going to form your answer, right? Somebody says, isn't it going to be divided by 5 if it was so? Now, to simplify, you can simplify. You can leave it like this, fam. You can leave it like this if you want. But I always want to try and simplify the best way possible and see that becomes your answer from that perspective. All right, so we're good to go. I'm ready for my next one. Taking this out. Gone, gone, going, gone. All right, we're ready. This is out. There we go. Okay, now that I've done the arithmetic, I'd like to go to the geometric sequencing, right? Or the geometric series when you're summing the terms of a geometric series. Let's go quickly. Write that subtopic right there. All right, summing the terms of a geometric series. Okay, now, basically speaking, when you've got a geometric series, it's because you had a geometric sequence. So the geometric series is taken from the geometric sequence. Hence, my statement says a geometric series is the sum of a geometric sequence. All right. And so the formulas for calculating the sum of a geometric series are the ones that you see there. It says Sn is equal to A, then R, because when you deal with geometric, we deal with the constant ratio R. R to the power n minus 1 over R minus 1. And I put a disclaimer that says you can use this formula when R is greater than 1. That's my disclaimer right there. You can use this formula when R is greater than 1. Now, we need to determine, again, who are the letters. N is the number of terms, the same way we did it when we dealt with arithmetic series. Again, for geometric, the sum, the formula is this. And we're saying N is the number of terms that you're summing. Sn, the sum of n terms. R, the constant ratio. And then you've got your first term, which is A. And also there's another way to do this, another particular formula. This one says Sn is equal to A, 1 minus R to the power n over 1 minus R. And you use this when R is less than 1. But let me say this because I want people to understand this. When I put this disclaimer here, the one that says use when R is greater than 1, when R is less than 1, is purely for mathematical simplification. But I want you to understand that you can use any of them. They'll still get you the same answer. But for simplification of maths, you can use this one when R is greater than 1. You can use this one when R is less than 1. Either of them will give you the same answer. And I want you to note and remember that. And again, the letters still stand for the same thing like the previous one. Your N, your Sn, your R, and your first term. So these are the formulas for calculating, the formulas that we're going to use to find the sum of the terms of a geometric series. All right, that being said, I want to go and see if I can do some questions. Maybe write down these formulas quickly and maybe the disclaimers as well. But as I go through the questions, Mina, I really don't care which one I use because I can get the maths right. So you can decide whether to use according to the disclaimers or not. But I want you to know that it's just for simplification of mathematics. All right, I'm ready. There we go. So we're now doing practice examples on geometric series. I'd like you to write that one down. Practice examples on geometric series. Let's start. I am ready. Geometric. All right, question number 1A. Find the sum of each geometric series, the one that you're looking at there, 2 over 27, 2 over 9, 2 over 3, up to 9 terms. Find the sum of each geometric series. Let's just gather our information. We're doing 1A. So the first one is that A is 2 over 27. That's your first term. Then the second thing that we need to note is my R. And if you go back to the topic sequences, for a geometric, constant ratio R is found by saying the term in front, which is 2 over 9, divided by the term before it, which is 2 over 27. Eventually, your R is 3. So the term in front, 2 over 9 divided by 2 over 27. Or you can say 2 over 3 divided by 2 over 9. You still get the same answer. It's a constant ratio. Then you're summing up to 9 terms. That means my n is equal to 9. And since R is greater than 1, I'm using what I gave you. We'll use this formula. Sn is A, then R to the power n minus 1, all this over R minus 1. We'll use this one since R is greater than 1. Then eventually, we're going to put our values, and I want you to help me out in the calculator. 2 over 27, the value of R is 3. I'm summing up to 9 terms, minus 1. All this over now R, which is 3, minus 1. I would like you to get me an answer quickly for 1A. Talk to me, fam. 1A, what are we looking into? All right, 728.96. I think they left it as a decimal. You can leave it as a fraction, which is 19,687 over 27. So I'll just put it as 728. Doesn't matter which way you put it. It's still going to be the same answer. 728.96. That's the sum of up to 9 terms. So that's 1A. I want you guys to try B. I want you to try B. Hey, I know. I want you to try B. I'm putting you on the deep end. 2 minutes, go for B. You should be done. The first term, A, is negative 64. I'd like to get my R. So my R will be the second term, which is 32 divided by the term before, negative 64. And so my R should be negative a half. Then I'm summing up to 10 terms, so N is 10. And so because R is less than 1, so I'm going to say Sn is A. I'm going to use this one. Like I said, fam, this is for ease of mathematics, but you can still use the other formula. You still get the same answer. So the first term being my negative 64, I just want to see what answer you get. 1 minus my R is a negative a half. I'm summing up to 10 terms. All of this over 1 minus a half. Don't forget to put the brackets. When you put a negative, learn things step by step. What number am I getting? Is it a negative or a positive? Because I'm getting different numbers here, so I don't know what you guys are getting. Negative 341 over 8. So I'll take that. If you're afraid of, and I think let's just be clear. Maybe let's just leave it as a fraction. It's always easier. Because the decimals, now you need to round off to 2 decimal places or whatever. Just leave it as a fraction. It will be okay. So negative 341 over 8, sum of up to 10 terms. All right, let's try and go for 2A quickly. For 2A, I'm going to do 2A with you. A very interesting question on that one. Thank you so much. Others are getting different answers. Just try and re-put this in the calculator. Be careful of the signs and everything, and you will get the number negative 341 over 8. Let's try number 2. Let's try number 2. Now, please note, and I just want to pause here a bit, the way I teach, I start with simple questions, just simple exercises. If you go to the end of my handout, let me just show you, yo, guys, I've got so much. Let me just show you. Where's my handout? You see, it goes on and on and on and on and on and on. Just want to show you just how much I have prepared for this lesson, right? And then these are the past exam papers. You see, all this 2019, 2023, 2010, even from back then, 2014, different places, so that everyone can get and understand all of this. So I want you guys to notice that I start small, but then I build up my story, okay? I start small, but then I go crazy towards the end so that everyone can fully understand. So it's a very comprehensive lesson. So these are just your small, hi, how are you kind of questions. Then the ones where we now ask each other, what is your favorite color? The past exam papers, that's what you will have. I'm ready for 2A. I'm ready for 2A right there. 2A says, how many terms are in the series? How many terms are in the series? There's a statement that I gave you where I said the position of the last term gives the number of terms in the series. I gave that statement. And it looks like to me, negative 1 over 32 is my last term. It's geometric. So according to geometric, Tn is AR to the power n minus 1. Oh, let's do maths, man. Let's do some maths. The value is negative 1 over 32. It's equal to A, which is negative 64. Follow me, I'm here. And then R, okay, let's do it on the side. R will be term number 2. There you are, which is negative 32 over term number 1. There you are, which is negative 64. So R is basically half. So I've got my R here as half to the power n minus 1. So that's what I have currently so far, and I'm hoping that we're good. Remember, guys, what am I looking for? I'm looking for the number of terms. I'm not looking for the sum of the terms. I'm looking for how many they are. The next question is when I'm looking for the sum. Currently, I just want to know how many terms are available here. Then on the second one, I can then find the sum of those terms. Okay, all right, say we hear you, we hear you. Break it down for us. Now, don't be Chuck Norris. Chuck Norris is a guy who used to act movies a long time ago, and no one could beat him because he was very good. Do not be Chuck Norris. Whatever you do, don't do it. In other words, I'm saying you can't say negative 64 times a half. Kanjani, bro. Kanjani. Because this half is to the power n minus 1. It is an exponent. You can't just multiply like that. Don't be Chuck Norris. In other words, you need to find a way of playing around with mathematics without necessarily being multiplying in. So what do I do now? It's negative 64. Bracket half to the power n minus 1. Well, I can divide both sides by negative 64. Hayibo se kanjani? Well, you can say negative 1 over 32 divided by negative 64, and I get a number like 1 over 2048 is equal to a half. It's an exponent. It's an exponent to the power n minus 1. On my YouTube channel, there is a video on exponents that I did for 2 hours. Please watch it, fam. Please watch it. Let's do some maths. I will say, in the laws of exponents, I'm looking for n. I'm looking for the number of terms. I'm looking for n. This is 1 over 2048. This is 1 over 2. Now, notice the following. You see, here at the top, I got a 1. I got a 1 here. Bottom, 2048. Bottom, 2. Now, it's possible that I can write 1 over, right? Then I say to my calculator, now listen to this. I know most of you guys are using a Casio calculator, so you'll follow me on this one here. I said, okay, somebody says, please go back again, say, no problem. I mean, I'm here, and I was saying, you can't multiply negative 64.5 because the laws don't allow it, because half is to the power n minus 1. So this is basically an exponent. So you can't just multiply it with normal numbers just like that. So I said, why don't we divide everything by negative 64? So I divided negative 1 over 32 divided by negative 64. I end up getting positive 1 over 2048. That's what I end up getting. Then I'm saying to you, okay, how do I actually solve this? Because if I remember something, and let me just use a side example here. Now, if I remember something here, fam, if I say it to you, 3 to the power x is equal to 3 to the power 4. Once the bases are the same, drop the powers. So x is equal to 4. So the conundrum that we have here, the problem that we're currently having here, is that the base is a half. And this side is 1 over 2048. The bases must be the same. They must be the same, the bases. So then I need to find a way around this. So then I say to myself, okay, let me play around with maths. There's a 1 at the top. There's a 1 at the top. There's 2048 at the bottom, and there's 2. Is it possible that I can make 2048 into a base of 2? Yes. The Casio calculator, you say 2048 equal to, then you say shift, then there are things written fact or comma somewhere there, just under the square root sign. So 2048, do it again, 2048 equal to shift, comma, I get 2 to the power of 11 is equal to a half. All right, to the power n minus 1. Still, I'm not satisfied. It's not good. It's not good at all, because this is 1 over 2 to the power 11. But let me show you something in maths. You know, in maths, if I say to you 1 over 3 to the power 4, it's as good as saying 1 over 3 to the power 4, because 1 to the power 4 will always give you 1. Then at the bottom here, you stay with 3 to the power 4, you go back to what you had. So 1 over 2 to the power 11 can be written as 1 over 2, all of that to the power 11. Now, suddenly, my bases are equal. A half. Okay, guys, let's go back. Say 1 over 2 to the power of 11. Then, in essence, this is good as saying 1 over 2 to the power of 11, because 1 to the power of 11, we can always go back. It gives me 1. Then 2 to the power of 11, I end up at the same place that I was. Drop the powers, drop the exponents. The bases are now the same. Drop them, and I see other people are already there. So the value of n is 12. So the position of this value is position 12. And because it's the last value, it means there are 12 terms in this particular series. And that's number 2A. 12 terms in that particular series? Okay, talk to me. All right, let me see if others have problems. I want to see what's going on. Oh, the calculator thing, others will help you right there. Say you are powerful. I love it. Hey, we're not. Hey, yo, sing happy, man. So somebody says, okay, repeat the calculator thing. I think someone is writing what you do. You just simply say 2048 equal to 2048 equal to, and then shift, comma, comma, comma. It's something that's at the bottom of the square root sign. All right, so like something like that. All right, something at the bottom of the square root sign right there. Okay, I'm ready for my next one. And then now that we know the number of terms available, we can now say what is the sum of the series. So I think we're good to go. What is the sum? How many terms are we summing? We're summing up to 12 terms. So what is the sum of this particular series? Let me take this out because I need some space here. I'm hoping people have written or are writing, or there you can take a screenshot if you want. That's still fine. I'm about to take this in the next 10 seconds. B, what is the sum of the series? You're summing up to 12 terms, sum of the series. So now here we are, S12. We can use the formula, any of them, but because R is less than 1, so I think we can use this one. That says this, okay? So my first term is going to be negative 64. I need your help, please. And then 1 minus my R is a half, I think, to the power 12. We're summing up to 12 terms. All this over 1 minus a half. Like I said, either formulas will get you to the same place. You don't have to worry. For mathematics and ease of it, that's what you would do. Talk to me, fam. I need an answer. The sum of up to 12 terms. Sum of up to 12 terms, up to 12 terms. What you talk about? What you talk about? Talk to me. Give me an answer, fam. Give me an answer. Somebody's got an answer. Negative 4,085 over 32. Let's just leave it as a fraction. Thank you. I agree with this. So it's number 2. That's number 2. I know what, I still have a feeling that we need something similar. Somebody says 95 or 85. I think it's 95. Yeah, should be some 95 here. Some 95. Let me correct this here. Should be 95, ne? Yes. Somebody says over 35, over 32. Guys, what is it? 35, 32, what is it? Get me an answer, give me an answer. 4,095 over 32. All right, perfect. Thank you. That becomes your answer for that. I still feel like we need to do something similar to what I did now. I want number 3, hey? I would really like to try number 3 with you. I really want to try number 3 with you. All right, so this was just number 2. Let's quickly go to question number 3. Right there, gone, gone, going, gone, gone. Perfect. This is out. All right, number 3. How many terms of the geometric series? Oh, this is interesting. How many terms of the geometric sequence, this one, and this one, will add up to this? Okay, this is not the same like number 2. I thought I'd find something similar, but it's fine. I'll work with it from there. In fact, you know what? Let me do number 4. Okay, let's do number 3. It's okay. It's okay. It's okay. We can do number 3. How many terms of the geometric sequence is this? And then you guys will do number 4. How many terms of the geometric sequence will add up to this? Let's read the English and understand it. We don't know how many terms add up to this. We just know that the sum of those terms is 364 over 27. We also are clear that A is 1 over 27. Can you please get me my R for this particular geometric? So it's going to be 1 over 9 divided by 1 over 27. I think the R should be 3. if I'm not mistaken. Thank you. I love it. And so using the formula that we use, when it is greater than 1, we'll come to this. Then we'll do this way. So then at the end of the day, we are then going to say, what is the sum of those terms? Well, it's 364 over 27. What is the first term? It's 1 over 27. What is R? It is 3. How many terms are you summing? You don't know how many terms. So then here, I'll have it as 3 minus 1. So you don't know how many terms that you add that will give you this number. You really do not know. Algebra, the mother of maths. Let's go. Bottom, 3 minus 1 is actually 2. And then can I cross multiply everything by 2? Where I say 364 over 27 multiplied by 2, I think I should get 728. All this over 27 is equal to 1 over 27 multiplied by 3 to the power n minus 1. Again, please, fam, don't be Chuck Norris. Just don't. 1 over 27, leave it there. It's fine. It's fine. Then divide everything by 1 over 27. Divide everything by 1 over 27. I end up with 728 is equal to 3 to the power n minus 1. I'm looking for n. How many terms I'm summing? I take n to the other side, or 1 to the other side rather. I get 729. And so I've got 729, and then is equal to 3 to the power n. The calculator thing, it says to me 729, 3 to the power 6 is equal to 3 to the power n. Eventually, the value of n is equal to 6. So it looks like 6 terms will add up to give you this value of 364 over 27. Right, you let me know where there's something that you don't understand so I can be able to, okay, people are getting this fine. Say, is it possible for a sequence to have an addition sign between the terms? Maybe not really. I see where the problem is there. Right, maybe I wanted to put the plus. Probably should have put a plus there, but basically it's a sequencing from that perspective. All right, sequence series. Remember, you get a series by adding the terms, so it's still pretty much okay. All right, I'm ready for my next one. I want you to try number 4, and I'm going to give you 3 minutes for that. Number 4, get a bit into it. 3 minutes. Let's go. Number 4. All right, I think others are done. Let's really confirm this quickly. Out, gone. So I think you've got the sum of up to n terms. It says determine n if when you add them, you get 765. Okay, so my A is 3 quickly. My R is 2 because 6 divided by 3 or 12 divided by 6. And then my Sn, sum of those terms is 765. And then I want to find my N, how many terms do I need to sum to get to that point? I'm very proud of you. You guys are getting an answer. I just want to confirm if that is the answer. I think you use this one here because your value of R is greater than 1. So I'm thinking you use this one. Like I said, you can use any of them. You still get back to the same answer. So that's A. And then my A is 3. Let me take this out. So that's 3. And then R is 2 to the power n minus 1 over 2 minus 1, which is 1. Cross multiply by 1, you get the same guy everywhere. That's 3. That's 2 to the power n minus 1. Then I think you can divide everything by 3. You end up with 255 is equal to 2 to the power n minus 1 to the other side, 256. I think I see where you're coming from. You change 256 to the base of 2. That gives me an 8, 2 to the power n. Drop the powers. N is 8. Voila, you did well. All right. I'm happy. Let's see if we can try something else right there. So I'm hoping people got this right. Let me move on to my next thing quickly because I want to also touch on other aspects of this. There's something more interesting coming on the next page. I'm about to take this out in the next 10 seconds. I'm about to take this out. Gone, going, gone. Boom. There we go. All right. There we are. Here's an interesting question. Question number 5. And I'm going to do it with you. In a geometric series, T6 is negative 243 and T3 is 72. Determine, number 1, the constant ratio. Number 2, the sum of the first 10 terms. Let me teach first, and then you guys will take it up from there, right? Here we go. When you deal with the geometric sequencing, you deal with this situation like this. Tn is equal to a r to the power n minus 1. So if I'm dealing with T6 as an example, it's a r n is 6. Okay, so it's going to be 6 minus 1. So it's a r to the power 5. So in other words, what to note is that T6 is a r to the 5. And I can play around again with T3, same thing. See, it's a 6, then minus 1, that gives me a 5. So T3 will be a r squared, or a r to the power 2. That's what T3 is. You can do around with anything. T12, a r to the 11. T25, a r to the 24. So it's 1 less. And so the story says to me, T6 is negative 243. A r to the power 5 is negative 243. Then I hear that T3, a r to the power 2, is 72. Equation 1, equation 2. And the question says, please find the constant ratio. There are many ways of doing this, but let me show you a very easy way. So now, if you notice equation 1, the power is 5. Equation 2, the power is 2. 5 is bigger than 2. And both of them have got a r 5, a r 2. So you can say equation 1 divided by equation 2. The equation with the highest power divided by the equation with the smallest power. Say, equation 1, a r to the power 5 divided by equation 2, AR to the power 2. But AR to the power 5 is negative 243. And then here I've got 72. Talk to me. Let me just pause there just in case someone does not understand and wants to ask a question. But this is my situation right now. So AR, I say the one with the biggest power divided by the one with the smallest power. And why am I doing this? So that I can eliminate the A's and remain with R, which is what I'm looking for. Because then mathematically, the A's cancel out. Then the powers are, the bases are the same. I got an R here. I got an R there. And so they subtract 5 minus 2. Just like what you do in exponents. X to the power 7 over X to the power 4 is X to the power 7 minus 4, which is X to the power 3. R to the power 5 over R to the power 2 is as good as saying, let me bring it here, R to the power 3. Then you've got the numbers that are standing for those terms, negative 243, which is AR to the power 5, divided by 72. You end up with negative 27, all this over 8, right there. Negative 27 over 8. Let me see if you guys are on the right track with me here. Then eventually you're going to find R. If this was R squared, you say square root. But because it's R cubed, you say cube root. So you cube root negative 27 over 8. And finally, your value for R is negative 3 over 2. And that's how you get your R. Negative 3 over 2. So thank you for that one. We got that answer right. We're good to go. So that's number one. They wanted the constant ratio, and we found the constant ratio, which is R negative 33 over 2. So again, there's many ways. You could have made A the subject of the formula here and substitute it into equation 2. That's still okay. But because I saw the A's, I'm like, but they can cancel out. Why don't I say equation 1, AR to the power 5 over equation 2, AR to the power 2. Then I get negative 4, 243 over 72, cube root, and so goes my beautiful story. All right, I'm ready for question number 2, 5-2. Question number 2, right there. Let me just erase this part. So please remember how you work around with this, fam, all the time. Please do remember. Do not forget that. Okay, I'm ready. The sum of the first 10 terms. So we're looking for S10. I think the formula I can use is the one way, because R is less than 1. So I can use this particular formula. But I have a problem here because I don't know A. I really don't know what A is. But no worries. I can find A. I can use equation 2 or I can use equation 1. Either of them will get me my A. So the first thing is to actually find my A right here. And I remember that in equation 2, which I will use, AR squared is 72. The R is negative 3 over 2 squared is equal to 72, which is A multiplied by 9 over 4 is equal to 72. So therefore we say 72 divided by 9 over 4. I think you get the answer 32. So find your A, you divide both sides by 9 over 4. So A is 32. Then maybe now you're going to bring it here and say, I'm looking for the sum of 10 terms. My first term A, I just found it as 32. 1, my R is negative 3 over 2 to the sum of 10 terms. I need your help. Over 1 minus, that's negative 3 over 2. Then eventually, what answer do you get? I love the comments. Say you're heavy. I'm giving you all the belts. Oh, Sugamatot. Love it. That's what you get from Mr. X, guys. I'm the guy that can get you a distinction. Trust me. And if you go to my social media pages, you'll be able to see all the testimonies and everything. I can get you there. You guys have not seen anything. Yo, wait until I teach you physics. If you want to see how very good I am in all of this. Wait up until I teach you physics and I explain stuff and you're like, wow, I did not know it this way. And so maths, physics, my forte, my kind of thing. So let's work it out from there on. What answer did you get, fam, eventually? Talk to me, fam. Talk to me. Talk to me. Hennessy. Wow. All right. Talk to me what you get when you now get the sum of 10 terms. The sum of up to 10 terms. So somebody says negative 11,605 over 16. Thank you so much. That becomes your answer for that one. So we're learning step by step what to do and how to do it. I want to go to something more interesting. Two more things here that I want to just pull across and end with. These things are definitely your sum to infinity and the sigma notation. Sum to infinity and the sigma notation. Let me take this out quickly. Let me take this out. Okay, in about 10 seconds, I'm going to take this out. Gone. All right, let's start off with sum to infinity, and I want you to pull across with me. Now, I will explain, and you will eventually understand. The word infinity means never ending. So we're looking for the sum of a series that does not have a last term. Sum to infinity. That's what we're looking for. We're looking for the sum of a series that does not have an ending. All right, let me give a basic example of that. Look at this. If you consider this sequence here, or this series, you can put it across as a series as well. Half plus a quarter plus 1/8 plus 1/16 plus 1/32. So it goes on. If notice something here, the denominator keeps doubling. The numerator doesn't change, 1, 1, 1, 1. So after 1/32, I expect 1/64. After 1/64, I expect 1/128. After 1/128, I expect 1/256. I'm giving you an idea. After 1/256, I'm expecting 1/512. After 1/512, I'm expecting 1/1024, 1/2048, 1/4096. So goes the story. This does not end. Because when I get to 1/1,000,000, the next one is 1/2,000,000. The next one is 1/4,000,000. It is a sequence that does not end. All right. Interestingly, if you think about it, at first glance, if you keep adding more terms, 1/64, adding more terms, 1/128, adding more terms, 1/256. If you keep adding more, you think that the sum of this series will increase. It doesn't. In fact, the more you add, the more it gets close to 1, but never 1. You can even try it. You can add the first 5 terms or 6 terms, then add another 10 terms. The answer that you keep getting keeps getting closer and closer to 1, but never gets past 1. Never. And okay, so I'm saying to you, keep adding terms. Keep putting them on 1/1/1/1/1. Your answer will never be greater than 1. In other words, the more terms you add, the sum of this series gets closer and closer to 1 but is never 1. And mathematically, we can then think and say, okay, since this number of terms don't end, they are infinite. Then since they get close to 1, the more I add the terms, maybe the sum to infinity is 1. But hold that thought. They don't get past 1, they get close to 1. So this is an example of a geometric series because the series does not end. And I want you to understand this. Oh, I love this. When you've got a series, and after adding the terms of the series, and you keep adding more terms of the series, the sum of that series keeps getting closer to a certain number. We say in mathematics, the series converges. So the series is converging. Why? Because the more terms you keep adding, it is getting closer to a certain number. The more terms you keep adding, it gets closer and closer to a certain number. It sums to a certain number. It is a converging series. All right, so say Utiena, if a series is converged, if a series keeps getting added, or the terms of a series keep getting added over and over again, and they get to a certain number, that series is converging. But here's more. Here's where the maths that you're going to be dealing with comes in. So if a series converges, one thing for certain is that the value of R should be between -1 and 1. And I want to read the statement because it's a very important thing. In a convergent series, where the constant ratio, where the constant ratio R is always strictly between -1 and 1. So every time you've got a convergent series, and how do I know it's convergent? The more terms you add, you sum to a certain number. And one thing about a convergent series is that the value of R, the constant ratio, is always between -1 and 1. And you can try it here. If you find R right here, 1/4 over 1/2, the answer is 1/2. And the value 1/2 is between -1 and 1. So if the value of R is between -1 and 1, we're speaking about a convergent series. Then the next big question that comes up is this. All right, say the terms don't have an end. They get to whatever value. They are infinite. So mathematically, is it possible? And that's why the subtopic says sum to infinity. Is it possible to find a sum to infinity of a typical series like this? Yes. What formula do I use? Welcome. Sum to infinity is A over 1 minus R. So we use this formula, the sum to infinity formula, to be able to understand that when you've got a typical series which is convergent, where the value of R is between -1 and 1, it is possible that you can get the sum to infinity of that particular series. A over 1 minus R, where A is normal, where sum to infinity is S, that one. A is the first term, and R is your constant ratio. Now, just to open it up a bit, listen to me. Then I'll do the questions with you. If a certain series, the more terms you keep adding, the summation becomes larger and larger, or smaller and smaller, right? Not close to a certain number, but smaller and smaller. Like very, very small. You keep decreasing, or you keep increasing. That particular series is diverging. That's why I put on my last statement. If a series keeps on growing infinitely bigger or smaller, it is not possible to calculate a value for it, and we say this series diverges. The converging one, the summation of the number of terms that you keep adding over and over again gets to a certain number, it doesn't become infinitely bigger. It does not become infinitely smaller, but rather it gets and converges to a certain number. That's what you call the infinite series. And because it's an infinite series, we're then saying to ourselves, the value of R is between -1 and 1, and we can get the sum to infinity. Love it. All right. Say you've said a mouthful. Show us then. Show us in questions. And Lesego says, Iyo say, you are more than powerful now. Asbong. All right, let's go. Practical examples on a geometric series, particularly we're dealing with the sum to infinity. I'm ready with this. So let's go for it. So practical examples or practice examples on this one. Work with me, fam. Work with me. All right, I'm ready for this one. It says to me, calculate the sum to infinity of the geometric series. Calculate the sum to infinity of this geometric series. I'll start with A. So the sum to infinity from the formula is A over 1 minus R. So your A is actually a half. And then 1 minus your R is also a half, because you'd say 1 over 4 divided by 1 over 2. So eventually your answer is 1. You see, this example is what I was using before, the previous slide. And I told you that the numbers get close to 1, but never past 1. So the sum to infinity will actually be 1 from there on, right? And then further on, look at B. B is more nicer, right? This is just A, and I want to do some B right here. Guys, I appreciate your comments. Keep them coming. Someone says, I got 57% in matric. Trust me, now I will get a distinction. Fire. Nazo. All right, let's try B. Let's try B, fam. Let's try B. B says, from here on, consider, and I'll just do B. Let me take this out here. Oh, B is interesting. Consider the infinite geometric series. P plus 1 plus P plus 1 squared plus so goes the story. For what values of P will the series converge? Now, I love this kind of questions. I've actually passed exam paper with that kind of thing. It says, for what values of P will the series converge? Work with me. Work with me. If a series converges, then -1 is less than R is less than 1. Now in this series, your second term, T2, is actually P plus 1. Your first term, T1, is actually P. That means at the end of the day, my R, which is T2 over T1, which is P over P plus 1 over P, the P's will cancel out. So my R is P plus 1. But the question says, for what values of P will the series converge? Convergence is available when -1 is less than R, and my R is P plus 1, less than 1. Let's do some maths, all right? Less than 1, let's do some maths. For what values of P? I can take plus 1 to the other side. That becomes, and that's what you do in maths. Plus 1 to the other side, that becomes 1 minus 1. That gives you 0. Plus 1 to the other side again. That gives you -1, -1. That's -2. So for every value of P between -2 and 0, the series will converge. One more time. Get the T's and C's. When does the series converge? It converges when -1 is less than R and R is less than 1. Okay, that's fine. That's okay with me. Can I get my R? Yes, I can. And so at the end of the day, I will have my P, my R is P plus 1, and I bring this and say, okay, convergence is available when -1 is less than R and R is less than 1. Then I take the 1 to the other side. What I do on the left-hand side, I also do on the right-hand side. So then +1 -1, because the plus, when it jumps, it becomes negative. 1 minus 1 is 0. Here it also becomes negative. -1, -1 is -2. So therefore, at the end of the day, it means to me the values of P, which will have this series converging, is between -2 and 0. Is that okay, family members? All right. Okay, perfect. I love the comments. Thank you so much. All right. Let me try the next one. Let me try the next one, okay? Thank you so much for this beautiful comments. I'm with you on this one. All right, I'm ready. Somebody says, if I meet a question that says calculate the sum to infinity, and okay, let me read this, and I get R that is greater than 1 or less than 1, do I write the series is divergent? Yes, but in your level, luckily for you guys, we only deal with convergent. Thank you for that question. But for your level, we only deal with convergent, not really with divergent, right? So it's not really going to be dealing with that one from that perspective. So that's what you have there. Thank you for those questions. I'm taking this out. Gone. Let's try this one. Assuming the series is convergent, thank you. Calculate the sum to infinity. Sum to infinity is always about a convergent series. A, 1 minus R. My A is P. Then 1 minus R, which is P plus 1. Let's do the maths. It's going to be P over 1 minus P. Guys, every time you put a negative, don't be Chuck Norris. Every time you put a negative bracket, and then here, minus 1. Then the math says, okay, P over P, guess what? The answer is 1. The answer is 1. All right, somebody says, Sam, may you please explain 1B again? Okay, no problem. Maybe just write the next one here. This should have been a 2. I think I made a mistake here. Should have been a 2, B2. Right there. All right. Maybe let me show you something. Let me show you a past exam paper, because I think I'm itching to do a past exam paper. That is the same idea. The one that asked me a question, you will probably get this from a past exam paper as well. Let me take this out. Gone. Right. Let me see if I can rush quickly to it. This was just, this is moving, move. There we are, past exam paper. Okay, this is a 2019 Northwest paper, prelim paper 1, question 3. I actually want you to write the title, right? Somebody says the answer is -1. Yes, I think it's -1 because it's P over -P. That's correct. Thank you for that correction from the previous one. It's -1. Thank you. All right, maybe write the title and I will do the question with you. And the one who asked me, you should be able to get the answer from here or get the explanation. So write down 2019 Northwest Prelim, paper 1, and it's question number 3. I haven't put the marks, 3 marks, 4 marks, so that's interesting. All right, here we go. Consider the geometric series. There you are. For which values of x will the series converge? I think it's similar to the one that we did before, but then let's think. I can find R first. Apparently, R is term number 2, which is this, over term number 1, which is that. Let me see. Can I? Yes. There we are. So I think the 5s and the 5s will cancel. And then gone. Then you've got 3x minus 1 squared over 3x minus 1. Then I think it cancels. Then I think basically you're left with 3x minus 1. That is your R from there on. Then the question says, for which values of x will the series converge? Last I checked, I heard that convergence is available under this situation. So -1 is less than 3x minus 1 is less than 1. So I'm going to find the values of x for which the series converges. And so look at this. I can take -1 to the other side. It becomes a +1, I get a 2. What I do on the left, I do on the right. Even at the same time here, I can take the -1 to the other side. It becomes a +1. -1 plus 1 is 0. So then I'm left with this one here. Okay, let me write it nicely, a bit closer. So that's my 0 right there. Then I can divide everything by 3 to make my life easy so I can get x. I can divide 0 by 3, I still remain with 0. And then 3x by 3, I've got x. Then here by 3, I've got 2/3. Apparently, in maths, it means for every value of x between 0 and 2/3, this series will converge. So for what values of x will the series converge? Between 0 and 2/3. The key is to find r. Then when you find it, bring it into the conditions. Then from there on is algebra. What you do on the left, you do on the right. If you're adding on the left, you're adding on the right. And you're dividing on the left, you're dividing also on the right. So for all values of x between 0 and 2/3, this particular series will converge. That's 3.1. I'm hoping the one that asked is able to understand this. Let's go over 3.2 very quickly. All right, so 3.2 says now we need to calculate the sum to infinity. 3.2 says now we need to calculate the sum to infinity. Write that 3.1 down and we go for 3.2. We need to calculate the sum to infinity. Right. I'm about to take this out. Gone. Let me see. All right, good. Gone. So the sum to infinity will actually be a over 1 minus r. My a is 5, 3x minus 1. And the question says, calculate the sum to infinity of the series if x is -1/6. So now I know what x is. So I can get my a from there. What you get for a, please tell me. What you get for a, what you get for a, what you get for a. Tell me what you get right there, and I need to find r as well. When you substitute there, everything there, what you get for a, 3 times -1/6, that's -1/2. So I get -15/2. Right, there's a question, I'm just reading it now. I'll attend to that question now. Sorry about that. So I got my first term a as -15/2. I just want a confirmation of that. Thank you. Then I can get r. Remember r from the previous question, we said is 3x minus 1. So where there's x is just -1/6. What do you end up getting as r? Talk to me. -3/2. Thank you. So then now we can bring these guys to this formula so that we can be able to say a is -15/2 over 1 minus r, which is -3/2. And then we get an answer for that. Somebody has a question? Go ahead. I'm all ears. Go ahead.
So, could you please confirm like a's value, because I got -35/2 instead of -15/2.
Okay, let's confirm that together. All right, let me do it this way. So 5, 3 times -1/6, that's -1/2, minus 1. So this 5, that gives you negative 3 over 2. 5 times negative 3 over 2 is actually negative 15 over 2. Just check again. You should be able to get that negative. So they are correct. It's actually negative 15 over 2. It's very correct. Just recheck. Or you can say here, if you don't want to put the brackets here, you can just say, maybe that could have been the issue. 3 times negative 1 over 6. You still get the answer as 15 over 2. Then I think what we're trying to do here, I'm seeing people putting the number negative 3. And here we are, and that's what we have. All right, guys. So basically, that's just a bit, a bit of sequences, or rather of the topic series. And why I'm saying a bit, guys, because I would need to do part 2 of this. Part 2 is when I deal with the one thing that was giving you a run for your money, which is sigma notation. Somebody asked, say, will you be able to teach us how to prove the formula? Not today, please, because I just wanted to lay down a background to what you guys need to know. But I will come through to all of these things and take it up from there. Please write this down. Just want to take you a bit backwards so that you can see what kind of situations I will be having. So let me take this out. Gone. There you are. So basically, the only thing that we're left with was this part. Oh, there's so many beautiful parts here, right? The summation up to, or this one of sigma notation, which is what I was definitely going to try. I'm going to do that for my part 2 so that you can be able to see. It gets more interesting. And once I do sigma notation, then I would run to go and do past exam papers. You have no idea. I am a huge fan of past exam papers, a huge fan of past exam papers. If you see what's happening here, these are past exam papers from different years, all this. When you attend my classes, when I start my regular proper classes, like I said, guys, I don't do this for free all the time. Obviously, it takes a lot of work for me to gather all this information, to type, to do this, and that takes me a lot of work. But in essence, I will tell you this, I will be able to help you the best way possible. All the single time that you need help, I got your back at any particular time. If I was to give you advice, I would say start early, look for help. I've taught many people before and they've passed and they're at different places. And so if you look at this, I'm just going to put this for the last time and then just so that it's a reminder. So listen, fam, this was our free lesson for maths. I did not finish it. No. I only did part 1 of it. There's still more parts left that we'll need to do together. And so once we get to those parts, we will align ourselves to that and take it up from there. So let me just try and open this up. Yes. Let me see if I can pull this. Give me a second. Oh, trying to go back to the beginning and all. But we tried. I think I like you guys in the sense that you're very hardworking. You look like people that are interested in this. And so you'll be able to work it out with me from there on, right? Okay, look at this. Let me just point something here. I see a hand. I'm going to attend to it now. All right, so I was saying, I'll give you more information for all my paid classes. And I'd say to you, last year it was 100 rands for a 2-hour lesson, but this year it's just basically 50 rand for a lesson. But the key or the catch is everyone must have a minimum of 2 lessons. That's all, right? Maximum lessons in a month is 4, but minimum would be 2. So at every particular point, you're going to pay 100 rands and it will give you 2 lessons. And each lesson is like this, is 2 hours long. And I will up and help your marks. I'll get you to a distinction moving from level 3 to level 7, from level 5 to level 7. If you're in level 7, I'll keep you on level 7. If you could go to level 8, we could go exam tactics, top range notes. I've got everything that you need to enable you to pass. So I know you guys will eventually make it right there. Somebody has a question. I would like to unmute. Go ahead and say something.
Hi, sir. I would love to start off by saying thank you so much. You really saved my life. You somehow you partly answered what I wanted to ask you. Well, I was asking if, was this our only free lesson, or is our next one the one where we're gonna start paying monthly? Or is this an every week thing, or what? Or are you gonna provide further information for us in the group chat?
All right. So what I'm going to do is I'm going to try and provide further information on the group chat. I will try. I'll try to do free lessons as much as I can, but I don't really do free lessons all the time. So somebody's put something across, and I like what they said. They said this was a trial version, ne? And so can you please screenshot that? My phone is off now. Somebody needs to screenshot that. This is a trial version of Mr. X Maths class. When the fun starts to kick in, then this message comes in, please upgrade to premium. So it's like that. I'll do another free lesson on physical science, actually, in the not next week, the other week. Physical science, I'll do a free lesson on it. I think I'll do organic chemistry on physical science. But then basically, guys, this is how our lessons go. They're very informative. You get a lot of resources. You'll be able to work at your pace, and it's convenient. And you'll be able to understand more. I'm a firm believer in getting resources from as many places as possible. Don't just work with one thing. Work with many streams. A sea becomes a sea because it's being fed by different rivers. River this, river that, then suddenly it's a sea, and you will have a sea of knowledge because you're coming from Mr. X and then his notes, then maybe your teacher, and then what? You need as much help as possible. Hence, I've made these lessons affordable for everyone, cheap for my people and other people, so that at least you can be able to get what you need and all. I really, really appreciate you guys today, and I thank you for coming into this lesson. What I'm going to do now is I'm going to stop the recording, and then I will deal with the group later on. And maybe if there's someone who came in and doesn't know and understand what we're here for, what my numbers are, 073-974-8498. I'm going to write it on the chat as well. There's 073-974-8498. Text me for more information on Mr. X. On Sunday, I'll be doing the grade 11. And maybe you can come through as well, because it's exponents, which is giving you a run for your money and all. So we'll be able to do more from there on. I'm going to stop the recording now.